All right, so for number 1, it's asking what type of change is occurring if I go from f of x equals a cube root of x to f of x is negative 1/3 cube root of x. So regardless of the parent function, what we're really going to be focusing on right now is the negative 1/3. That negative 1/3 is going to tell me two things. So one is going to be a reflection over the x-axis. So if I look at my options, I can go ahead and get rid of A and C. And then 1/3. So that's going to be a vertical compression, and it's a vertical compression because 1/3 falls between 0 and 1. So we're going to do a vertical compression, which is D. All right, number 2. So it says, what is the maximum or minimum value of the following function? Is it a maximum or minimum? What's the value? So the first thing I'm going to do is I'm going to look at my graph here, and I'm going to plot those values. All right, so I see that I have a minimum. So we're going to have a minimum here, and that minimum is located at 2, -3. But it asks me what is the minimum value. So when we talk about the minimum value, we're going to focus on the y value. That's how low is my graph going. So my minimum value is going to be -3. All right, so then for the next one, which is the most accurately describes the translation? So we're not starting with the parent function this time, but we're going from this function, let me get my little, this function to this one. So how did we go from +4 to nothing here? So I would look at this, and if I'm going from +4 to nothing, that means that I would have had to have subtracted 4. And then if I'm at +1 to -3, that means that I would have had to have subtracted 4 as well. So in order to do that, if I'm subtracting 4 in this section, that means that I'm going to be going to the right by 4 units. And if I'm subtracting 4 in this part of my equation, that means I'm going to be going down 4. So we're looking at D as our option. Now, another way to look at it is to look at it graphically. So I have y equals x plus 4 squared plus 1. And then we have y equals x squared minus 3. So if I turn this off, I can see that here is my original vertex, and I can see that I'm going to go down 4 units and to the right 4 units to give me my new vertex, which is exactly what we got. All right, so domain. Remember, domain are your x values, so I want to know from left to right. So we're going to start the domain on this side, and that is going to start at -4. Now I have an open circle right here, so that's going to be a parentheses, and everything is in continuous here, and then we stop at 1, but that one has a closed circle, so that's going to be a bracket. All right, so for the next one, it says the graph of the function is shown below. If the graph is translated 3 units right and 5 units down and reflects over the x-axis, what is the new equation of this function? So basically what we're doing is we're asking what would the equation look like. So my original would have been just my absolute value function up here. So how did I get from this one to this one? So if we go to the right 3, so remember that's going to be right is going to be the opposite of what we think it is, so -3. Down 5, so -5, and a reflection of the x-axis, the negative on the outside. So giving our answer is going to be B. All right, so this one talks about end behavior. So remember, end behavior is asking where did the ends of my graph go. So I'm going to start this off by graphing my function here. All right, so we have our ends. So if I kind of drew a sketch here, something similar to this, and I'm asking where are my ends of my graph going here. So on the left side, my graph is going down. On my right side, my graph is also going down. So if I'm on the left, x is going to be approaching negative ∞, as y approaches negative ∞, because I'm going down. And then on the right, x is going to be approaching positive infinity, because we are going to the right, and y is going to be going to negative infinity because we're going down. So when I read this, I've got to be very careful, because when I'm looking at my pieces, it starts with my y value. and then it gives me my x value. So I kind of got to read it backwards. So I'm looking at as x approaches infinity for the first one. So this one says as x approaches infinity, y approaches negative infinity. That is true. So then we have as x approaches negative infinity, y approaches negative infinity. So the correct answer is actually going to be A. So again, be careful. Make sure you're reading it correctly. Make sure that you're looking at that. Make sure the x's are the correct x piece and the y is the correct y piece. All right, so then we have the graph below. They want to know what is the maximum minimum value. So here's my maximum. So my maximum value is going up to 2. So that's going to give me a y value of 2. And then my minimum here is going down to negative 2. So I have a maximum value of 2, a minimum value at negative 2. All right, y-intercept. First, easiest way to do this is to do it graphically. The other option I'll show you in just a second. All right, so we're going to look at our graph. We're going to see where it crosses the y-axis, and we see that it crosses at 0, 4. Your other option is your y-intercept are always going to be your constant values. So I have two constants in this problem, which are negative 12 and negative 3. So negative 12 divided by negative 3, positive 4 is my y-intercept. All right, the mapping below, if we create this map here. So in my map, I have my x values are negative 3, 0, 3, and 5. And then my negative 3 is going to map to 1. My 0 is going to map to 6. My 3 is going to map to 2. And my 5 is going to map to negative 1. This is pretty basic. Make sure all of your pieces are going to the correct numbers. When I'm looking at this, I can see, it's kind of hard to see here, but you can kind of see these two arrows. When we do this, the arrows are only supposed to point to the right. So that's not going to work for D. So I need one that has negative 3 to 1, 0 to 6, and it puts them in order, which is exactly what we are seeing here with A. Is this a function? It is a function because there's no repeating x values. All right, so where is my graph increasing? So remember, when we increase, we read it from left to right. So we're going to increase until this point, this maximum. Then it's going to decrease. And then it's going to decrease, and then we're going to start to increase again at that minimum. So it's increasing from negative infinity to negative 1. So this one, we're going to check all that apply, and then it's going from 1 to infinity. So we're starting back here and going from 1 to infinity. Now, and it wants to know for the next one, which one of these is a positive interval. So in order for it to be positive, it means it's above the x-axis. So anything above the x-axis is a positive interval of the graph. So I'm going to estimate here. Obviously, on your test, you're going to know exactly what values you're looking at, or it's going to be multiple choice. So this interval is going to fall, we'll say, negative 4.5 to negative 2.3-ish, okay? And then this one interval is positive from 0, and it's going to stay positive until about 3.25. All right, so the intervals are always the x values. I cannot stress that enough. Intervals, unless it clearly states y interval, when I ask you for the interval, especially increasing and decreasing, positive, those are x values, okay? All right, so the next one, it says, what type of discontinuity exists here? So I can see that this graph is discontinuous. And it's discontinuous because it has an asymptote there. Now remember, removable discontinuity means I would take a point out of your graph, physically take it out. Infinite means that I have two sections that are completely separated from each other, and they're going in infinite directions away. And then jump means that I'm going to jump from one point to the other. Now, whenever you have a vertical asymptote is always going to be the infinite discontinuity, okay? Infinite discontinuity is always going to be a vertical asymptote. Now it wants to know the domain. So we figured out that we have a vertical asymptote at 4. So that means 4 is not part of the graph. So we're going to come from negative infinity and we're going to approach 4. And then we're going to pick back up on the other side of 4 and go to positive infinity. So the correct answer here is D. All right, range. Range is going to be my y values. I saw a lot of people got this wrong on the practice, more or less because you gave me the domain instead of the range. So the range is your y values. All right, so y values. So we start from the bottom and go up, okay? So if I draw a little sketch here, this point right here, this vertex, that point is negative 2, negative 3. So we're starting at negative 3, and we are going up to infinity. So when we talk about the range here, that point is included. So it's going to be bracket negative 3 to infinity. All right. The next one is kind of close together, but it asks for the roots or the x-intercepts. Again, I would suggest you graphing these and look for your x-intercepts. All right, so when I'm looking at this, I can see that I have an x-intercept here at negative 2. So I have negative 2, and I have another x-intercept at 6. They could give it to you in point form, which is fine. So negative 2, 0, and 6, 0. All right, so the next one, it says, the figure below shows the graph of the function g of x. So this is g of x over here. And it gives me f of x. So how is g of x related to f of x? So I need to look at both of these and figure out what happened. So I have y equals, and I have 2x and squared minus 1. So when I look at this, I'm going to hit my little home button. I can see my vertex started down here at 0, 1. 0, negative 1. So what had to happen for me to get from that point up to this point? Well, we had to go up by 3. So we had to take the original f of x and go up 3 units. So therefore the answer is A. All right, so this one asks, which one of these has a value that is decreasing from negative 1 to 1 and increases from negative infinity to negative 1 and 1 to infinity? So this is going to be you typing in each answer and figuring out which one works. Well, this one, when I'm looking at the graph, I can see that it is going to decrease from the left and then going to increase. So it doesn't actually change from increasing to decreasing multiple times. So that's not going to work. So I have x squared again plus 2x plus 1. Same concept here. I'm decreasing from the left. It stops decreasing around negative 0.5, starts to increase again. That's not going to work either. So then we have our next one. And we have x cubed plus 3x plus 5. Now, this one is increasing the entire way. It never stops increasing. It just keeps going. So that's not going to work. So finally we get to our last option and we find that we are increasing up until this maximum, which is negative 1. And then we're going to decrease from negative 1 to 1, which is exactly what we have here. And then we're going to start to increase again. All right, we're going to start, well, if it'll let me click it, we're going to start to increase again on this side over here. So the correct answer is D. All right, so then it says, what happens to y as x approaches positive infinity? So it's asking you for the end behavior here. That's what we are looking at. So if we're looking at the end behavior, obviously I'm going to want to graph this. And I can see that it's asking me about x approaches positive infinity. So if we're talking about x approaches positive infinity, we're asking about the right side. So over here on this right side, it's going to level out and it's going to keep approaching and keep going, but it's approaching a horizontal asymptote this time. So it is approaching the value of 0. It's not going to keep going down to negative infinity because it's never going to cross over that x-axis. It's approaching 0. All right, so then Joy analyzed this graph below, and they want to know, based off the key features that she got, were there any incorrections, and what were they? So I think the names got mixed up. Joy, Jonathan, same thing. All right, so we have the y-intercept is at 0, -1. I think we can agree that the y-intercept is at 0, -1. That's a true statement. There's a maximum at 2, -5. Well, there is a extrema point at 2, 5, but this is actually going to be a minimum. And then finally, they got the end behavior that as f of x, remember this is y, so as x goes to -infinity, so as we go to the left, y is going up, so this part is true. And then this one says as x approaches 4, so x is going to approach 4 here, because that point here is 4, -1. My y value is going to approach -1. That's true as well. So what they got wrong was the vertex. The vertex should have been a minimum. All right, if you have any questions, please don't hesitate to ask, and let me know if you need to do a Zoom session or whatever it may be in order to